Welcome back. So I've been doing some research. Some perusing. Bring up the Earth, bring up the magnetic anomaly map. Okay. So close that. Okay. I was talking about Tamu Massif in the last episode. So definitely see that one for some prequel information, and see the ones before that. Particularly the I think I called it Oceanic Plateaus playlist, possibly Large Igneous Province playlist, one of those two. So we're talking about how the Earth expanded. That was an odd place. I was not looking there. And the evidence, and looking at the evidence, we were looking at Shatsky Rise at Tamu Massif. The work of William Sager, which I opened a bunch of articles from after the last episode. I just went through his lecture on YouTube and ended up being like, okay, what's up? And once I started looking at some of this research, I just went down a rabbit hole. So we're gonna go through this rabbit hole. There's some really, really like exciting things I'm finding to corroborate other things that I've talked about. So hopefully you're acquainted with my research enough that this makes sense. I'll try my best to at least like give a quick framework. So generally speaking, my interpretation is that the Earth expanded and the Western Pacific plate was under North America, like this, physically positioned over here, with its general boundary around here, around there, in terms of North America. But then over here was Australia, like this doesn't have Australia depicted because it's on a expanded globe, so it's hard to like put the pieces back together in the current radius, so I just have the islands. But Papua New Guinea is attached directly still to Australia in terms of continental crust. And then adjacent to Papua New Guinea, connected to Australia, was Sulawesi and North Maluku. And then connected to that was Philippines. Connected to that was Borneo, which I don't think I have positioned well up there because there's a lot of details. But like this was the Western Australia, where Borneo, ignoring this stuff up here, this is not really relevant in terms of this animation. Obviously it's relevant, just not in terms of this animation. So like this was kind of down here, and then this region up here was just down here, and then Indonesia, a current involved in its formation process, flowed in here and opened this gap. And the Philippines were broken up away by current flows that flowed in this region of Philippines to physically sever it from behind this way. And then also interacted with Borneo in ways I haven't really looked into that much, but like it just kind of fit along with the others. Whereas Eastern Australia, this is probably lacking some details, I realized. Like New Zealand might be up here specifically, but it might be down there. So it might actually be kind of not relevant, but I think it might have been initially up here at a time and got moved down and then over. Not certain, but there's reasons to believe it was up here and got moved down, as we'll kind of go into some of the relating details as we go. But this is how it was initially, where Solomon Islands were connected here. So if we go back to this one, we can kind of see here's Solomon Islands and beyond. Right here is this like shape in the Solomon Islands. Here's a shape in the ocean floor. They're kind of similar in a way, where what I've called the broken bond. So a bond broke, and then there's one here. So they've got that cross thing, this opening that's kind of shaped similarly to this back there. There's parallels across here. Parallels between the Juan de Fuca region and Philippines, even though there's nuances to that for sure, but in essence they were there. Okay, I don't want to get too held up on details. Here's one other animation of specifically California, Sulawesi, and North Maluku, where we see like parallels. Una Island, Sutter Buttes, San Francisco Bay, Banggai Islands being like mirrors of one another. This huge basin, Australian shelf over there. Okay, so that's another one. Okay, so the work of William Sager brought to my attention the concept in geology of what's called the Jurassic Quiet Zone. So this video, we're gonna go through this thread I wrote. It's very long at this point, very long, many posts. I don't even know how many posts. So we're gonna try to go through it pretty quick, as quick, but as like thorough as I can. Okay, so some reason I didn't link this paper. Maybe I link it soon after. I don't know if I did. I might have just I think this was from one of William Sager's papers, but the region between the red lines in the first image here is known to modern science as the Jurassic Quiet Zone, which is the reason it's called that is because there's not. So if we go to the magnetic anomaly map, this is a period of what's called rapid reversals, I think. Like there's a reversal in the magnetism according to current interpretation, the way we look at things, where these are depicting times in Earth's history when the magnetic field changed, and then it imprinted that change in the rock itself to create these variations in magnetism, so that there's, let me move myself a little bit. Got a new monitor, which is pretty exciting. I don't have to like hit record and stop record in the video itself anymore, and I can do a little more research a little better that way, and other things. I can watch stuff like the Wheel of Time. I was just watching, and oh my god, I love the Wheel of Time. I read it as a kid, and I just love it. So I don't know if you noticed, if you watch a lot of my videos, there's a lot of references to Wheel of Time concepts. It's just cool. But I finished season 2. I was like, I gotta rewatch that. So I was watching it today. Like, yay! While I was searching through these papers. Anyway, this is called I believe this is not the Jurassic Quiet Period, because it's got all these changes in the magnetism. This is the Jurassic Quiet Period here, but it's very much not our quiet zone. It's very much not quiet, it's just not understood very well. So we're gonna get into some details I found. There's some, which had led me, what's really awesome is this led me to some things that are so just like, mwah. I'm stoked. So anyway, so the Jurassic Quiet Zone in this red area, and then there's other. So if we go back here, like over here is called the Japanese lineation set. Over here is called the Hawaiian lineation set. Over here it's called the Phoenix lineation set. So there's these names, as we can see here, which are considered spreading zones, like it's spread outward from here or something of that nature. As it grew, like it gets younger, the further away it goes, it gets younger. Like, but out over here, similar in age to this, is similar in age to this, gets younger. So they're kind of related in that way. Okay. And I said, comically named as per usual, with descriptions opposite to their nature. So I notice sometimes things in geology will be named in ways that are just utterly the opposite. Like, this is not a quiet time in Earth's history. It's actually a very intense time in Earth's history that's documented in this area. Because Australia was adopted, so if we... before, literally North America had the Western Pacific under it, as well as Australia had the Western Pacific. So like there was North America, Australia, and then the Western Pacific under them both, portions of them both, not entirely. That was just forming this like under layers of the Western Pacific, and then as the Earth expanded, the crust broke apart, and this Western Pacific was most attached to Asia. So as Asia moved away and Australia moved off of it, it basically was revealed from underneath the continents and became the Western Pacific, and then it continued to expand outward to a point where the Eastern Pacific formed. Okay. And I've dubbed the Eye of the World. I forgot. That's right. I called this the Eye of the World. I forgot this post mentioned the Eye of the World. This location once had Australia's ammonite formed above. So here's the Eye of the World. So if we look here, like there's a physical circle here. And there's more than one. There's one here. There's one over here. Like generally there's roundedness around here. They're probably all over the place, just atop one another, to a point where it's hard to see. But even if we look at the Earth itself, especially from this angle, I feel like we can see right here like a circular ring of seamounts. That is what I have dubbed the Eye of the World, which is actually, as we'll find out, is called the East Mariana Basin. So here's the Mariana Trench and etc. here, and then to its east is the East Mariana Basin here. And then over here is called the Pigafetta Basin or something, which I have not looked into very much, but apparently it's the oldest crust, or at least that we're able to find crust of, dated. So here's the Eye of the World. Here's the ammonite under Australia that was forming. This is probably where the Eye of the World was. I'm not completely certain. Over here seems to be where Shatsky Rise was, like over here. Shatsky Rise over here. So it might not have been, or it might have initially been. It's hard to say. I haven't really established this position. The Pacific is so complex to really fully put together in that kind of way. especially when you need to account for like which things formed when and the sequence of events. Mind you, radiometric dating is not actually valid for absolute ages, but it is very useful for relative ages because this process was very rapid and essentially was the decay of the Earth radioactively as a fractal atom where it radioactively decayed. And in so doing, the atoms of the Earth radioactively decayed and essentially painted this picture of large amounts of time passing that really didn't pass. So without accounting for the Earth's expansion process inducing radioactive decay and then back calculating by figuring out exactly how much across time, it's very hard for us to realize that using modern decay rates and looking at, like, yes, we can use the radioactive decay as a dating method, but we have to account for all the details to do so. If there was in the past this period of large-scale global radioactive decay that we're not accounting for, then it would look like it was a long time ago when it really wasn't. Okay, because essentially Earth entered a new equilibrium, just like a reaction, there's reactance, there's an activation energy, which then induces a reaction very rapidly, and then a new equilibrium, where the reactants are in an equilibrium. In order to bring them to a new equilibrium, there needs to be a certain amount of energy input, which has then led to this change between states, which is observed as the expansion of the Earth as well as the global flood. All sorts of things. Okay, let's keep going. We're only looking at the first post, so let's keep going. The main eye, there are many circular structures, is presently known as East Mariana Basin. So there's a picture of it, East Mariana Basin, and the main eye. And then I put this in there. Mind you, if anyone's curious, it uses Twitter. Like if you click the thing, I have a full screen. I have a what's it called? An extension that allows me to full screen, I think specifically Twitter GIFs. So I can actually full screen it, but this is limited to 10 megabytes unless I pay, which I just haven't and am not very interested in, although maybe I should have. I just don't agree. I'm like, no. So there's that again, and then there's that again, so we already talked about that. There's another picture with Papua New Guinea, Solomon Islands, kind of adjacent to Mexico, as well as if you kind of squeeze this in, like bend it in, you can visually see how it would bend so that this region of North Maluku and Sulawesi would bend into California. And then Philippines are so far over there initially that it's hard to visualize, and they're also moved, so there's all sorts of details with the Philippines, but this we can see at least. And then over here is a region of interest. The Ontong Java Plateau is here, which we've kind of talked about pretty extensively, so hopefully you've seen that. Also, one of my videos, thanks Gary, I didn't even know that I could watch, that my videos were watchable with closed caption. I try to watch it on YouTube at least. Sorry if you watch on Rumble and if my videos have been taken off YouTube by the time you see this, and you're just seeing it on Rumble where there's not a closed caption, so it's not really applicable. But on YouTube, the closed caption is functional in my videos and seems to work even with background music that's really loud. Episode 361 is ridiculously loud background music. I listened to this one, I pre-recorded a little bit. I think this music should be okay. It's definitely audible and maybe a little loud, but when I talked, it was definitely not even comparable, so I figure it's fine. So here's generally how they were, and then I just did it several times at different angles. So here's on-tongue Java. Here's without on-tongue Java. Just kind of showing. You can even see they got like similarities in their appearance, but also again kind of mirrored with this like straight thing. Where here it's like it's a bay, California Bay, Gulf of California. It's a gulf. Here it's a mountain chain, so it's kind of mirrored, but it's still doing a similar thing to up there, but opposite even, interestingly, where this one's the one that's like eroded by water, and this is the one that's like built up even more so to have this mountain chain. Okay, so there's those. Okay, next post. Interesting aspect of a lack, let's just click this, a lack of substantial sediment cover in the Jurassic quiet zone, as if it formed more recently and was overlain. Wait, is that what we're looking at? Not completely sure that that's. As if it formed more recently, was overlain by continents until it emerged as the Western Pacific. Oh yeah, that's right. The Western Pacific in general. Western Pacific Jurassic crust. Despite great water depth, only a few hundred meters of sediment covered the fast-spreading crust. So this is... I guess I finally linked the paper here. I was like, okay, there it is. This is from this paper. All of the previous posts that had anything technical in it were like this image. It's from this paper, from Tommy Naga and William Sager. There he is. Nature of the Jurassic Magnetic Quiet Zone, also known the Jurassic Quiet Zone. So magnetic because it doesn't have the stripes, and it's just kind of looks like this. So it's quiet because it doesn't have the stripes that are just pointing to things. It doesn't really mean it's quiet per se. But anyway, only a few hundred meters of sediment cover the fast spreading crust. So if you just think about it, like imagine hundreds of millions of years this crust has been exposed to water, and the water has been in contact with other crust, higher elevation, and that water is going to this area and bringing material there. Like, it should deposit more than a few hundred meters of sediment covering the crust. Mind you, this sediment is specifically Cretaceous, I'm pretty sure. I think we'll get into it more specifically later, but I'm fairly certain it's literally Cretaceous sediment. So as I was saying over here, as if it formed more recently, so back to that, like, radiometric dating is useful for relative ages, but not absolute ages until we account for things with regard to the Earth's expansion process. If only thousands of years have passed, then this is more reasonable. And secondly, that it was overlain by continents until it emerged as the Western Pacific, so it didn't even have the capacity to be like fully exposed to the processes until it started to emerge by literally having Australia move off of it, and then it's more exposed. Like, deposits are flowing onto Australia. Some are probably getting down on it, but like until it moves away, it really lacks the capacity to have large sediment cover. So I just thought that was interesting that it kind of corroborates in that way. Nothing too like monumental, but just, you know, every little detail matters like that. Because if it's true, it's true, and it should be able to like shed light on things rather than like it's not like I ever find things and I look at them like, oh shit, I could never talk about this because it would disprove everything I've ever said. That doesn't happen. I mean, at least not with like the scientific stuff. Maybe the whole like you guys already know what's going on and you're fucking with me and you're trolling. And I just ignore it and keep going about my day as if like you guys don't have some like Truman Show shit going on and you're straight trolling me. I don't know. That aside, scientifically, like any evidence I look at is not like disproving. If anything, it like points to that I need to think about things a little more. But it doesn't really ever concern me. Like, there's nothing that, like, when this evidence is presented to me, I'm like, oh shit. It's just, like, I'll read a paper and, like, several things are very significant to what I've already said, is how it seems to go. Okay, so here's just, the low amplitude zone in this time frame. So took me a while to get any acquaintance with this stuff. The early M's, like M19 is more recent. M44, M42 type range are older. And so like I believe this is Jurassic period when this low amplitude zone is, but essentially when we look at it like this is a high amplitude, these pink, relative to their surroundings, but maybe in a certain range, wherever, maybe here, I don't know. I'm not sure where they're analyzing, maybe like here. In a certain range, they find low amplitude sequences, so I just kind of documented that. I didn't know what to make of it. Let's see what I said. Another figure as well as first above. Text image of previous. Oh, so it just said another figure. Here's another figure from this paper, and then mostly because I wanted to provide this link. And then I went on to say M29 chron. So a monotonic decrease. Let's just read this. In anomaly amplitude has been widely observed. I don't know what this means exactly. Let's just look up monotonic. Never decreases or never increases, so just kind of flattened. A monotonic flat, like a continuous decrease in anomaly amplitude. I don't know if that's what that's saying. Has been widely observed in the M anomaly sequence. I kind of just ignored this. Just mono, like the same tonic. Monotonic decrease in anomaly amplitude has been widely observed in the M anomaly sequence in all three lineation sets. So that's talking about the Japanese lineation set, the, if I go back here, the Hawaiian and the Phoenix lineation sets. So all of them, so essentially all of them have this amplitude decrease that is like this previous one, like this. In the M anomaly sequence, in the Japanese lineation set, anomaly amplitude decreases back to about M39, which marks the onset of a confused period of low amplitude anomalies. I don't know why they would call it confused, maybe confusing period, that are difficult to correlate. The low amplitude zone, LAZ, prior to the LAZ, correlation anomalies, correlatable anomalies reappear and become larger in amplitude further back in time, starting at 167 million years radiometric dating, which M42 is that date. Like, as far as I can tell, like, that's generally how this works. Like, certain lines are at certain times and correlate to one another. So, like, M42 here, at least in the Western Pacific, is 167, and M44 is 170, which is figure 2, which maybe was this one. These ones, so okay, let's just keep going. What did I read here? I think I was just documenting the dates and just noting also that they use the term confused to describe it and difficult to correlate, although that's probably more so just that they fade out than anything about like a fundamental lack of capacity in the models to understand. Compositionally, the East Mariana Basin basalts are uniformly low potassium tholiites that are depleted in highly incompatible elements. Whatever, I keep coming across this phrase, I haven't bothered to look it up. If you're interested enough, feel free to look it up. I'm just going to keep going. Compared to moderately, so there's depleted in highly incompatible elements compared to, so it has, I guess, more of moderately incompatible ones, which is typical of mid-ocean. So like what's kind of to bring it back to things, which is typical of mid-ocean ridge basalts, which is just like the basic basalt of the ocean floor. That which comes from the mid-ocean ridges is called a mid-ocean ridge basalt. Erupted near hotspots, so possibly with some like eruptive or mound building, like Ontong Java Plateau. I wouldn't say it's necessarily eruptive, although it does have some kind of characteristics where it's like building a mound. So it's like, well, it's a mantle plume, even though it's undercurrents colliding that are building up a mound, and other things that are talked about in other episodes. So like the nuance of it all is a little different, and I'm trying to read it in like to translate it. So it's typical of the East Mariana Basin basalts are typical of mid-ocean ridge basalts that have some kind of at least interpreted hotspot correlation. Also, this is interesting, they overlap with some Indian Ocean ridge, mid-ocean ridge basalts, so there's like a variation in the mid-ocean ridge basalts between Indian Ocean and other oceans that can differentiate, because basically the undercurrent is different. So like over here, there's currents coming out this way from the mantle puncture hole that are flowing out this way, and probably other places involved that are maybe more direct and interacting with this region, where over here in the Eastern Pacific, there's actually currents flowing from the same place that go all the way over here under Europe, and then under North America, fill North America, but then go under here and then form the Western Pacific. So they go much further. So like the potential that they're interacting and reacting with their surroundings, that means that they're gonna be varied in a way where they could be differentiated to a point where there's Indian Ocean ridge, mid-ocean ridge basalts. Okay, so they overlap with some, although they are distinct from the isotopic compositions of Jurassic basalts drilled in the Pigafetta Basin, the oldest Pacific mid-ocean ridge basalt. So the East Mariana Basin basalts here are different, and they vary from basalts up like right around here, I believe it is what that's basically saying. Isotopically distinct compositionally. The isotopic compositions of the East Mariana Basin tholiites are also similar to the isotopic signature of basalts from the nearby Ontong Java and Manihiki plateaus. So let's just keep going real quick. In addition, the new age of 111 plus or minus from argon dating in the Nauru Basin is indistinguishable from the age of the East Mariana Basin flows. So I'll pause there since I changed color. So up here, the ages are dated to Jurassic, which is greater than 145. It's like 170 or something up here. Over here, it's dated to like 110-ish or whatever it just said, which is comparable to Ontong Java Plateau and Nauru Basin, as well as Manihiki Plateau over here. So these have some correlation with this, is what it's getting at. That is different than this. Mind you, if we look at this again, like it's really like an eruption center, like a big caldera looking thing. I don't know if it's caldera per se, but it has that kind of vibe to me with all these circles. Like there's some eruptive forces going on here. So it's highly likely from what I'm, as we go forward, that this region formed in the Jurassic, but then in the Cretaceous it was actually erupted through, and possibly in like ring-like structures and not like entirely through, although maybe the East Mariana Basin is basically a huge caldera that formed there from some type of eruptive event. Although I don't know where that material would go. I kind of just picture it as like eruptions around the edge forming a ring. I don't know. I'm not quite sure what to make of it, but the fact of the matter is maybe the material is just here and around in the Jurassic Quiet Zone. Is this material is very young in a way that is not like, if we go like this, Oceanic Crustal Age. If I do this, there is no indication whatsoever that there's some variation here, because it's not being accounted for in these. It's just being ignored. This age here is the oldest, like 200, and it just gets younger going outward, ignoring the Mariana Trench nuances, gets younger going outward. No indication whatsoever. But what this is saying is it's only 110 there, where this is saying, if we go back here, it's saying this is 200. That's completely different. And that's what I'm finding, is a lot of these in the East Mariana Basin are saying this age. Notably, there's a lack of data. Like they're all referencing, let's see, just keep in mind site 462 as we go forward. If we see drill site 462, then that's an indication that they're all using the same data. Pigafetta Basin has drill site 801. That one has Jurassic. Okay, so let's just keep going. I've even put a star here. Thus, while magnetic anomaly patterns predict that the igneous basin in the Nauru and East Mariana Basins is Jurassic in age, like I just showed here, this is pretty much a prediction. The geochemical and chronological results discussed here suggest that the basement, so maybe I was mistaken, even there is no Jurassic in that region. In the East Mariana, there's Jurassic in the Pigafetta, but the basement formed during a Cretaceous rifting event within the Jurassic crust. This is crazy. I don't know quite what to make of it, but it's incredible. I'm just like, dudes, you know why this is not talked about? Because it would like really confuse things when it comes to plate tectonics. It's much prettier and easier to just ignore it than it's just this plate moving and all the generic shit we say. Oh, the plate's doing that. Okay, the plate's doing this. Okay, and then we move on, and like scientists over in America, like we're kind of look at these and okay, we look over there and okay, but most people don't know. Even geologists probably have no idea that this is an aspect of the reality of this earth, because it just is like it's a hole in the theory of plate tectonics, just like it's a hole in the Jurassic crust. Okay, so just to read what I said when I was reading it, so maybe a little more in the moment of my thought process. Another pattern, a paper by, so this is a different paper by Castillo et al., this one. Describes that the East Mariana Basin, which would be expected to be Jurassic in age, has evidence of having formed coeval to Ontong Java Nui at approximately 111 million years, and of similar materials, making it highly interrelated. So my thought, just initial thought of that was, this is formed by an undercurrent flowing physically into it. Like Papua New Guinea's over here, undercurrent is flowing, running into resistance, so it's building a mound, and maybe it's like redirecting the flow over this way, and maybe even underneath this crust where it erupts underneath here and erupts, and or just overlays. But I've yet to find anyone conclusively demonstrating this is actually has Jurassic basement layer of basalt. Everything I'm reading is, I mean, there's been a little bit because they look at regions up here and are like, well, therefore it's over here too, but they haven't really established it at all that there's a Jurassic crust here, and it may just be like this paper says, that it's a basement that is incompatible with modern predictions of plate tectonics. Okay, so another relevant paper is this one, also by Castillo. The Nauru volcaniclastics have incompatible trace element, and those ones. Isotope compositions typical of the Quambata, which in short, the tholitic lavas of the Ontong Java Plateau. So the Nauru volcaniclastics have compositions typical of the lavas of Ontong Java Plateau. The East Mariana volcaniclastics have isotope ratios typical of alkalic ocean island basalts. Their source is either this Goyet and the seamount chain. Oh wow, it's just whoa. Or I kind of ignored this because it didn't occur to me. Marshall Gilbert Islands are over here in this region. Let's just go like this. Marshall Islands. Over here. In short, in this thing going this way, look at where this is pointing at, just for reference. It's going this way. And right here, keep this spot in mind if you don't know what I'm talking about. I'll just point it out over here. It's this spot, and notice this. It's pointing at this, so this is very important. So let's go back here. East Mariana volcaniclastics have isotope ratios typical of ocean island basalts. Their source is either some goyet in a seamount chain, Ritak, which maybe is that same seamount chain. There's Marshall Islands. So it's probably, maybe I can even find it here. So still in this like straight line thing that's pointing over here. So interesting. East Mariana has materials that seem to be sourced from that stretch or the ancestral Manihiki-Hikarangi Plateau, which is part of Ontong Java Plateau. Ontong Java Nui was the combination of this one, and one. Hikarangi is right here. So a combination of these three, some components from particularly these two, and not so much Ontong Java, I guess I'm saying, and possibly this stretch are the source for materials over here. Worth noting. Other geological data argue for the Manihiki-Hikarangi Plateau as a source. This implies that the mid-Cretaceous Pacific upper mantle was dominated by the sources of lava that formed giant or oceanic plateaus, which is these undercurrents. But most importantly, the undercurrents were building up pressure because they're colliding and building basically mounds that are under the crust. They got nowhere else to go. They're just flowing around the earth and colliding, and then they build up these mounds because they're just getting pushed into that region that then builds up pressure in the mid-Cretaceous until the end of the Cretaceous, the KT boundary, which is when the earth rapidly expanded. The continents broke apart and the earth rapidly expanded at the end of the Cretaceous. But in the mid-Cretaceous, ignoring upper mantle part, sure, these are undercurrents from the mantle, in the upper mantle, so that's fine, but it's just a little too mantle plume was dominated by the sources of lavas that formed giant oceanic plateaus. Just really points to that the mid-Cretaceous was this build-up phase when the pressures were building. Sedimentation and Subsidence History of the East Mariana Basin by Joe Whitman. So I wrote another very curious paper describing the anomalously great depth of crust at the East Mariana Basin. Okay, let's go over here. Drilling results from the East Mariana Basin are used to establish the presence of very thick sediments, so there's very thick sediments, in the probable Jurassic Basin, believed to be, because that's what the magnetic anomalies point to, and that's what they indicate by our modern interpretations, but we're finding by drill results that's not necessarily the case. But so probable Jurassic Basin, the dominance of redeposited material derived from the surrounding seamounts, and an anomalously great depth of crust greater than 6,900 meters. The great depth to crust suggests that this region has had an unusual subsidence history, or that present models are not adequate to explain the behavior of crust of this age. Mind you, this is where this is happening. Hopefully I get to the detail soon. It's just gonna scroll down a little bit. Okay, we're getting to it. It's just worth noting right now that this is a thickening of the crust in the East Mariana Basin, and to an anomalous degree. And I wrote, as if the ammonite structure of Australia formation process caused it to be deflected downward in its formation more so than elsewhere on Earth. So, like, imagine there's undercurrents flowing, and they run into the formation of this ammonite structure here, like they're flowing into it. They run into a physical structure that's forming in an ammonite type of shape, because ammonites are not actually, they're abiotic, they're not biological. Yeah, whatever. And the current goes into it and goes down and up, but down, so it like produces an increased subsidence because it's got this huge system above it that isn't elsewhere. Like, these aren't all throughout the earth. This is really the only place on earth where this structure on this scale exists. So it flows into it but then goes under it, which then leads to this increased subsidence and depth of the crust. It's kind of what I'm thinking, coupled with that there's a focal point that maybe isn't actually here yet, or was here. Oh shoot, could that have been here initially? Like, if Australia was turned like sideways. Let's just go like this real quick. Just for funsies. Just for funsies. I'm gonna zoom in. This scale, go like this. Swear I'll find it. And we're gonna go over here and go like this. And then just kind of cut out this high intensity region. Maybe like that. Do that right? Cut OX. I did see. Okay, then delete that. And delete the other one. And then turn it. Let's say -90. Minus 10 more. It's pretty comparable size. I wonder if there was a relationship. Like, Australia was there with this current going across to this way. Like, I see this right here. And then it bends over. Maybe related to this siphuncle. I don't know, I haven't thought about that. I'm not saying it is, but that really would actually kind of make some sense, honestly. At least like initially, and then they moved apart. Let's go back out of curiosity. to this one. See kind of where this is relative to that. Not the same. I really think it was here. Maybe it started here and actually moved over there. As just like a focal point where things were flowing to. I don't know. That just occurred to me, so let's keep going. And another paper by Wallach and Steiner. The search for Jurassic basement within the confines of the Jurassic magnetic quiet zone has been fraught with a variety of problems, not least of which is the recovery of basalts and dolerites of an age inconsistent with that predicted from observed magnetic anomaly patterns. Something without encountering first leg to the drill site. Discontinued drilling after recovery of some 500 plus meters of Cretaceous volcanics. Re-entry of hole 462A on leg 89 penetrated an additional 137 meters of early Aptian or older basalt without encountering sediments or basement rocks of the predicted Jurassic age. Site 802 in the East Mariana Basin was drilled in the Jurassic Quiet Zone, a region presumed to be older than Polarity Crone M33 and hence having a predicted age of Middle Jurassic, which they did not find, like we just talked about. It showed it to be like 111, the age of Ontong Java Plateau, and the other Manihiki. Okay, another paper by Brian Taylor. There are several enigmas in current models for the Cretaceous evolution of the Southwest Pacific. First, the Phoenix M series magnetic lineations have no symmetric conjugates. I'm not sure if the second line. I think this is just first. Like he has a second. And I just kind of underlined first. I didn't know what to make of this first one. There's several enigmas, though, is why I start this. There are several enigmas in current models for the Cretaceous evolution of the Southwest Pacific. Various models involving ridge jumps, rifting, and various models have been proposed to explain this situation, but none resolve all the issues. Second, this is actually relevant. Instead, have no symmetric conjugates. Let's read this whole thing because I don't think when I was looking at this it occurred to me some things. Instead, the Ellis Basin, Robbie Ridge, and Manihiki Plateau occupy the area where the symmetric lineations are expected. So Manihiki is here, Robbie Ridge is here, and I'm not sure where the other Ellis Basin is, maybe here, I'm not sure. Various models have been proposed to explain this situation, but none resolve all the issues. Second, the Ontong Java and Manihiki oceanic plateaus have nearly identical volcanic histories and compositions, which is probably, I'm not sure, this is 2005, I'm not sure if Ontong Java Nui is like accepted at all in this paper or what. Ontong Java, Manihiki, Hikarangi Plateau, so probably is what that stands for. Plus, models for their Formation require an amazing coincidence. Let me just read the whole thing, sorry. Including formation volcanism at 119 to 125 million and secondary phases some 20 to 40 million years later, despite being separated by 2,500 kilometers. Lusk models for their formation require an amazing coincidence of events over thousands of kilometers and tens of millions of years, which is resolved in part by the Ontong-Java-Nui complex of all of these oceanic plateaus being once one, I believe. Third, mantle plume models for these plateaus do not fit several of their first order features. So not even like looking that deep, just at like first order. Mantle plume models cannot explain this, including submarine emplacement, minor subsidence with age for the Ontong-Java plateau. So one of the other papers I have in here mentions the subsidence is very low. It should be this much based on these reasons, but it's actually that much, significantly less. And how do we explain this? Mantle plume doesn't work for that kind of thing. The similar geochemistry of eruptions separated by so much space and time, and the lack of an obvious plume tail trace. Like, where did this plume go? Well, it went everywhere. Okay, then here's Ellis Basin. Here we go. Ellis Basin just to the north of Robbie Ridge. It looks like it's going all the way across this way maybe, or possibly there, starting at the islands, going that way to the east, and then Robbie Ridge, and then Manihiki Plateau from that same paper. Which then gets us really, we're starting to approach where I was like, wait a minute. Wait one gosh darn minute. East of Fiji, currents formed a figure 8 structure. So this is from my Earth's Undercurrents video, if you haven't seen that. And this is not, but the general concept, I like provide a basis for what I'm talking about in my Earth's Undercurrents video and all my other videos as a whole. I just don't know where to point to more precisely. Maybe something called the Angel or Trident in the name for this region, but that might be long ago before a lot of details are worked out. But currents formed a figure 8 structure around a focal point, this red region, that was initially along the boundary of Ecuador and maybe Australia, even before then, at that little tab on the eastern coast, under the eastern coast, not actually off the coast. This induced current jet streams northward in a trident. So basically currents were going like this, in this kind of pattern, in a figure 8, and some were going off down here in like a flame structure. So maybe this angel thing is not the best, but I just saw an angel in the snow and drew the lines, you know. But so this is an older picture too, but in so doing it basically induced a jet stream away off of the pole, like a gamma ray burst, but a jet stream off of this pole that then fans out sideways and goes up. And so let's go over here. This here that goes sideways and then goes up. We can especially see the upward, and then notice it doesn't just go up, it goes to where this like thick bars are, that in the middle of them is this circle. Here's another one going up, and there's a circle there, and more like pseudo one here. It's a little harder to see, but probably there, because there's that. And I think this one might even go somewhat sideways up this way, or up this way to that one, like fanning out that way more so, and then off this way. So there's these, which I've correlated to over here, this region, like that location where that big bar is to over here in the past. But then over here, that's when I'm like, wait a minute. And I did my best. I did my best to make this animation. Definitely not perfectly matched up. Taking coordinates. I didn't want to say I did my best again. Taking coordinates, the boundary of the trident does go up to Manihiki Plateau. So if we like go like this, if we go like this and say, I don't know, just like somewhere that's generally, here's the boundary of Manihiki, but like within it here, like right there. Let's go right there. 8 point, let's see. Or 167 and a little bit. And 8.5 and a little bit kind of thing. 167, 8.5. It's like right there. And notice where that is. Point right where this is. So this structure is shoving a current out this way that has a boundary that it bends against, a resistance it bends against. It literally, that thing is here, it goes up this way. I believe it goes here and not actually there. But let's see, let's get this one too. 10 points, let's get exactly 10. And then 170.67. Exactly 10 north. There's more there. So that's actually one of these side currents. Like the branches off, but over here it does it off this way and off this way. So it must have a current, the main current, and then a side current that is actually where this island chain is, and then the main current there with that. But it goes up this way and branches over and runs into Manihiki and goes up this way. And then it goes below Robbie Ridge, or above it maybe. Probably both, honestly, both above and below it to create the ridge. And in so doing though, like it demonstrates that this thing participated in the process of separation of Ontong Java Plateau and Manihiki Plateau. And if we just look at it, there's this flame structure going down this way. Here's New Zealand. And over here, I believe, somewhere over here, is the Hikarangi Plateau. So it probably did it to that too. Like this angel thing is connected to all of them. Ontong Java's over here, off of the like nose of the bird of Solomon Islands. Like the beak of the bird, I guess. And the eye area, like off of there. And then Hikarangi is to the east of northern New Zealand. Here's northern New Zealand, so Hikarangi is in this region. So it's like at the foot of the angel. At the foot of the angel is Hikarangi. In the wing of the angel, over here, is Manihiki. And then over here is Ontong Java Plateau, which maybe isn't in the angel structure so much, but I've talked about in the past how these same current lines can be found over here, and that this region is crust that was probably over here, and Ontong Java just moved it. Like whatever currents were flowing in and forming Ontong Java participated in breaking this piece of crust away and moving it over here, which is this area, like right in here. I believe. Let me just make sure. Yeah, off the top of the head of the bird. Top of the head to like the bond over here. Top of the head to the bond over here. So yeah, this region. This chunk was generally over here and got shoved out of the way as this formed by this thing. And so apparently what we're finding, that's why I found it interesting, the East Mariana Basin and these islands are composed, like, what is this composed of? Maybe it's composed of this. It looks like it could be composed of these things. It also looks like it could be composed of this, and maybe this. Like they all look the same. Why do they look the same? Because they're all being sourced from this process that this focal point is. So maybe let me just pull up the Ontong Java one in its full glory. So I made this Ontong Java Nui Trident. So notice here's Fiji. Maybe I didn't actually go back to it. Here's this thing to the east of Fiji. Why does this look so bad? It's kind of pixelated. I don't know. I didn't even look at it, I guess. Going up that way. Like the animation once I put the pieces together. Let's see how good this is. That's pretty good. That's pretty good. This is pretty good. I'm pretty sure over here is not so good, but it's pretty good. And Hikarangi or Manihiki over here. At the bend, maybe it's a little off over there. A little surprised that this looks like this though. Usually they look more like this, where they have like the full map and then they fade. And then they fade back to the full map like that. I don't know if I must not have put a like final frame in. So yeah, then I just said so much clarity because honestly, like this is distinctly related. And then I put this little GIF that I thought was appropriate because I just love it all. And the earth. And he's even hugging the Pacific, maybe even doing other things. The Pacific I don't want to talk about. Hey man, you do you. I know the eye of the world's there. Okay. Another paper by Janie and Castillo. So I kept looking around. Drilling conducted by the Deep Sea Drilling Project in basins of the Central and Western Pacific has repeatedly recovered Cretaceous basalts from portions of the Pacific Plate that are believed to be of Jurassic Age, based on the interpretation of magnetic anomaly data. Hugely anomalous. Who knows about this? Maybe some specialized geologist. That's about it. It's probably not even like a common knowledge in geology. Huge detail right there. Basalts from these two sites have ages of 110 to 115 in the East Mariana Basin or Nauru Basin, which are 40 to 60 million years younger than their late Jurassic crustal ages predicted. Huge discrepancy. The occurrence of these Cretaceous basalts prompted speculation that intraplate Cretaceous igneous complexes cover huge areas of Jurassic Age Pacific crust. So, way to maintain the paradigm without it falling apart is to come up with something. However, these igneous complexes are unlike other products of Cretaceous intraplate volcanism, such as seamounts and oceanic plateaus, in that they do not form distinct volcanic edifices, and for the most part, they are petrographically and chemically similar to normal ocean floor tholeiites. The tectonic evolution down here. I just didn't underline tectonic because it's just so easy to just insert tectonic and make it look like plate tectonics. It's true when it's inserting an assumption too. The origin of these widespread volcanic phenomena, not just tectonic because that assumes plate tectonics is still valid, is poorly understood but has serious implications for the geodynamic mechanisms responsible for effusive Cretaceous volcanism and for the accuracy of the currently accepted tectonic evolution model for the West Central Pacific inferred from magnetic anomaly data, but we could really remove that last bit there. And for the accuracy of the currently accepted model. Further states many revealing details in their conclusion section. So that was from the introduction, I believe. Yeah, that was their introduction. And then this is the conclusion of this paper, which can be found here. I'm going to link my thread, and I'll try to link all these papers as best as I can. Some of them I could only access with like temporary links that I definitely cannot just post the links. But conclusions. We have examined the chemical and isotopic compositions of anomalous Cretaceous flows and sills from these places in the northwestern corner of the Central Pacific Basin, predicted to be of Jurassic age, as well as Cretaceous oceanic crust from another site in the southern part of the basin, and have drawn the following conclusions. The major and trace element compositions of Site 169, which is in the northwestern corner of the Central Pacific Basin, tholeiites suggest that they were produced by high degrees of partial melting of a source, kind of like a gamma ray jet stream from like a cosmic body that's just this jet stream out of a pole. It's like high degrees of partial melting where it's just got like energy to it. Whereas Site 166 in the southern part of the basin, tholeiites were probably generated by moderate degrees of melting of a source strongly depleted in incompatible elements, which kind of, I don't know exactly where this paper might say where they read it. I'm not sure, or where these sites are exactly on a map. This paper might have them on a map. The chemical and isotopic, or it's just a thought, like maybe those are more sourced from the undercurrents in general than the like focused ones that are forming this angel structure in the trident, and that whereas 169 is much more related to the trident currents, maybe. The chemical and isotopic characteristics of Site 169 are consistent, which is the hot one, or the partial melt one. High degrees of partial melting. Consistent with emplacement at a plume-affected spreading center. That's kind of just for reference in a way. The chemical and isotopic homogeneity of the tholeiitic basalts from both sites in the Nauru Basin and Site 802 in the East Mariana Basin indicates that all were derived from the same type of mantle source and were emplaced in the same type of setting. Like that angel, the current. Trace element and isotopic data suggest that the sources of basalts from the three sites were enriched by mantle materials, which if you look at like my Ecuador video recently, the angel, or just like I said earlier in passing, the angel structure, that nucleus thing, was, in my interpretation, generally here, at least in its like highest intensity, where if we look at the magnetic anomaly map, I call it the secondary mantle puncture hole here. I believe it was here. So the secondary mantle puncture hole is providing perhaps some of this enriched by mantle materials. And then it says probably from the Ontong Java and possibly from Manihiki plumes. So maybe not unclear, because I don't know if those are like directly, although maybe they're heavily participating and interacting with currents from the secondary mantle puncture hole as well, enriching them. We propose that the tholeiites from, I don't know what this is, I feel like that just means basaltic tholeiites. From the East Mariana, Nauru, and northwestern Central Pacific basins were created at a short-lived system of spreading centers active in mid-Cretaceous time. I'm not sure if that fits for when this angel thing is definitely not stable on Earth. It was definitely short-lived, and it definitely ended by the end of the Cretaceous. I don't know if it was only active in the mid-Cretaceous time, or if that was more like, I don't know, extending from the East Mariana Basin into the northwestern Central Pacific Basin, probably initiated by the rapid formation of the Ontong Java Plateau around 122 million. This speculative hypothesis is consistent with chemical and isotopic compositions, but contradicts the currently accepted tectonic evolution model for the West Central Pacific region based on the interpretation of magnetic anomalies. So again, these anomalies, you can't just use them as straightforwardly as it is generally presumed, and it requires really being aware of this kind of thing to see that there's something else going on. Then I started looking at some other topics. The Cretaceous normal superchron is an irregular stable polarity period in which no or few geomagnetic reversals occurred, lasting from 120 to 83 million years ago. This time period I found of interest with regard to Baja, BC. I feel like there's some relationship that timing of things is almost like relieving, like the accretion of terrains in that area is like related to some mechanism of either relieving pressure, building pressure, something to do with that region, because the dates are very similar. I don't want to get too caught up on the central or the Cretaceous normal superchron, so let's just quickly read through this. Yoshimura further describes the CNS as a period of high large igneous province formation as well as volcanism in China, with western Pacific seamount volcanism active from 115 to 60 million up until just after the KT boundary. At the time of the CNS, the eruption of large igneous provinces was frequent. This has been termed the pulse during the mid-Cretaceous by Larsen. The large igneous provinces known to have erupted during the CNS period include Ontong Java, Kerguelen, and Rajmahal, which I haven't looked at either of those. I kind of have Kerguelen. Not really that one. Bengal, Silhet traps. I haven't looked at those, any of these four really. But the high Arctic large igneous province, which I talked about in the past, I know it's got a lot of nuance to it, and it might even be related to Siberian traps and other ones. See, I believe Full Circle 360 episode, I believe I talked about it there, possibly a little after. The Caribbean large igneous province, Madagascan flood basalts, which I haven't looked at, like the Gulas Plateau, northeast Georgia and Maud Rise, and the Hess Rise, and probably others. It is interesting to note that volcanism in China, production of granite and kimberlites were active during the CNS. So basically, this is a period where there's not magnetic reversals really. A period of high or irregular stable polarity in which no or few geomagnetic reversals occurred. I'm not quite sure what to make of that, because I'm still not convinced that these reversals are depicting the actual Earth's magnetic field at the time, but rather just like everything else, essentially like these things elsewhere, anywhere there's like something of this nature elsewhere where there's blue and there's red and pink. Blue is a place where current flowed, and pink is a place where current compacted material. Like over here, that's what's happening under continents, and mind you, this was happening under continents at the time. So I'm not really sure we know what we're talking about when we say those things. Like, a period of no or few geomagnetic reversals. Maybe there's also some aspects to it of the magnetic field that I'm not visualizing how they're connected, but it's not as straightforward as we think it is, that's for sure. Okay, I read that one. And then the cause of the CNS is an open question in earth science. During the CNS, there was a lot of volcanic activity and seafloor production. So this is the same paper. The numerical geodynamo simulation predicts a minimum heat flux at the core mantle boundary during the CNS, while the mantle convection simulation predicts a maximum heat flux. This is a contradiction. So there's like confusing aspects in terms of modern interpretations where basically we're connecting it to the core core mantle boundaries getting involved in this, which may or may not be valid. The two peaks of oceanic heat flow were roughly consistent with the onset of two supercons. So I don't know if there's two peaks of oceanic heat flow or flux, I guess, that are roughly consistent with the onset of the Cretaceous normal supercon, as well as the Permian Carboniferous reverse supercon. So over here I wrote, it is of note that both the CNS and the Permian Carboniferous reverse supercon precede, the Permian one precedes the Permian Triassic boundary, and the CNS precedes the KT boundaries, both times in the buildup of pressures leading into major physical breakup and expansion of the Earth. So even though the KT boundary is when the Earth actually like physically expanded to its present radius, there was a time at the Permian Triassic boundary when it kind of like an initial step in the process. I don't know exactly what happened. I think Australia moved. Like it was Papua New Guinea was way up by like what modern day Alaska region relatively, and it just turned and like reestablished a connection to North America sideways in the Permian Triassic kind of time frame, where at the KT boundary it fully expanded and the entire crust broke apart. So there's like a precursor time of the Permian Triassic boundary when some major Earth expansion step happened that is much more vague in my understanding. And then there's a truly like rapid expansion phase of the Cretaceous Paleogene boundary. Then these are described by Oliveira et al. As having distinctive dynamic conditions for the Earth during these intervals. So basically, I'll just read this. Our results indicate high similarity between the angular VGP, which is virtual geomagnetic poles, dispersion, whatever that means exactly. Sometimes I just read things, I don't know what they mean exactly, and that's okay. Like, there's no one out there who can read through every paper and just know. Sure, when it's your field, like, you might be aware of these terms more, but anyway, I'm sure the average person understands. I'm just talking to, like, experts who are, like, scoffing at or anyone who would doubt, who just are listening for the sake of doubt, I guess. Anyway, from those periods, in contrasting difference for periods of higher reversal rates, which they then say the last 5 million years, which is kind of interesting. It's almost like when it was slowing down, there were more reversal rates. Such evidence could point out similar heat flux conditions. And then they said in the core mantle boundary, but I kind of ignored that. Like, I purposely didn't underline it because I was just more generically could point out similar heat flux conditions. Like, that's when the Earth was about to explode because it's built up pressure. So there's a lot of heat flux conditions at these time frames leading up into when they fucking exploded. So in plain language, the Earth fucking exploded. One of the longest and special intervals that occurred between 262 and 318 million years ago. So that's when the other one, Permian Carboniferous reversed supercon, is, in which it did not reverse its polarity. The so-called PCRS. Notable similarity with another long single polarity interval, the CNS, which occurred between 83 and 121 million years ago, according to this paper, and probably whoever their basing that off of. These results are very interesting regarding the distinctive dynamic conditions for the Earth during these intervals. And then that's all I underlined, so let's keep going because we are just getting closer to the end, but not really there. How far is this? Hour and a half. Okay. This is gonna be 2 hours, I guess. Okay, fine. So, describe a third supercon, so then I just underlined this. Apparently there's another one, which maybe was of lesser... I don't know anything about it. My guess is maybe there was an even smaller, like, expansion step at the Ordovician reverse supercron. Let's see, is there a mass extinction at, like, 440-ish? Mass extinctions. Let's say big 5. Boom, baby. Still getting headshots. Boom, headshot. Sorry, guys. Counter-Strike days. What can I say? Okay, some interesting details about the Ontong Java from another paper. Engel and Coffin, pointing to anomalous characteristics while explicitly stating plate tectonic theory does not satisfactorily explain the origin of large igneous provinces. Plate tectonics, let's say it again, does not satisfactorily explain the origin of large igneous provinces. This paper is proposing the Ontong Java Plateau to be the result of an impact crater, or an impact, but I didn't really get into that. I just more so focused on the problems with the mantle plume model. So this is the one that maybe brings up subsidence. Ontong Java Plateau cannot be linked convincingly to the Louisville hotspot, or any other hotspot track, or currently active hotspot on the basis of these things. The a priori assumption that a deep mantle plume created the Ontong Java Plateau is based on its huge crustal volume. So it's fucking huge, so it must... Where's this coming from? It's gotta be from the mantle. What do you mean from the mantle? Yeah, deep down like a boom, a plume. And the unusual conditions required to generate such extensive magmatism. It's just an assumption that it's from the deep mantle plume, basically, is what they're saying. Like, educated guess, another way to put it. But maybe falsely educated, or if plate tectonics is false, it's not really truly educated guess. Oceanic crust should have been uplifted to between this amount. So basically, this is where they kind of go into the details. Emplacement of the Ontong Java Plateau up to 35 kilometers thick crust following uplift of pre-existing crust, oceanic 7 kilometers thick oceanic crust, should have resulted in major widespread subaerial volcanism at minimum, culminating elevations of these. Yet all Ontong Java basalts erupted below sea level, and sediments deposited just above this basement are marine. And somewhere else in here they say predicted total subsidence of 120 million year old oceanic crust ranges from this amount. The Ontong Java crust subsided only 1,000 to 2,800 versus 3,000 to 3,800, significantly less than either typical oceanic lithosphere or other oceanic plateaus and submarine ridges. So they're like, this doesn't make sense either. And then, oh, I said, oh, extensive fractional, I forgot about this. Extensive fractional crystallization of Ontong Java Plateau. And I said, almost like there was a mixing in the region that induced an eddy of sorts, like a swirling in the region. Meanwhile, there are eddies under Australia and at the figure 8 to its east that was centered on the secondary mantle puncture hole. So if you don't know my Mount Gurnar videos about fractional crystallization related subject, I'll just show you Mount Gurnar and say it was fractionally crystallized. Fractional crystallization occurred in Mount Gurnar. This led to separation of the materials. Mount Gurnar formed in a literal spiral of the basalt here, and you can kind of see it here, that swirled around it and then separated the materials, produced a core of diorite monzonite with all these other things, but then a ring of basalt with a hexagonal ring around the basalt, or that the basalt is in actually, of olivine gabbro. And then around the olivine gabbro is another hexagon, which I kind of draw all the details of in this line, but it's got hexagonal features like here, so it doesn't really capture the boundaries that well, but the hexagon around it is basalt again, and that basalt, instead of being a ring like this is basalt here, this is basalt here. This basalt has a ring of granophyre. So there's fractional crystallization that went on at Mount Gurnar, according to papers, although they don't recognize the vortex aspect of it, but I do. And so I immediately, when I saw the words, wherever they are, I don't know if it's in this one. Why is it not in this one? What did I post there? I must have just not even, as soon as I saw that word. The Ontong Java Plateau, East Mariana, and Nauru Basin basalts have similar ages, overlapping isotopic signatures, and generally comparable overall major and trace element compositions, and a common mantle origin for the Ontong Java Plateau and these basin basalts seems reasonable. Some common origin for them all. Mantle related. To generate the major and trace element patterns of the greater Ontong Java Plateau basalts requires partial batch melting of 30% or more, followed by extensive fractional crystallization. And if you watch my Earth's Undercurrents video, I even say, before seeing any of this stuff, way before seeing any of this stuff, I literally say differentiates the material like this right here. These currents inducing a field and differentiation of materials. Notice I got these dotted lines in this color and this color. I got the dotted lines of each color in one another because they're mixing. And fractional crystallization, I guess, is at play here. And there's that. And then this is going up that way. Material is ejected and jets secreted to Western North America as well. That's kind of crazy that there's fractional crystallization mentioned in this area. Oh my god. Such large degrees of partial melting are known in seafloor spreading environments influenced by hot or wet mantle plumes, or just hot or wet mantle material that has yet to solidify, but is still under the crust, but is not necessarily like still in the mantle region either. It's kind of in the boundary, lower crust region. Ontong Java Plateau basalts suggest in those ways melting and fractional crystallization at shallow depths. So again, like not deep depths, but under the crust kind of thing, comparable to magma chambers depths of normal mid-ocean ridge basalts under the crust, but not like in the mantle still. Eruption at ocean ridge crest depths is consistent with the absence of vesicles and greater Ontong Java Plateau lavas, indicating a minimum eruption depths of greater than 800 meters. So maybe not even all the way under the crust, especially in that area. So then I'm like, whoa, dude. Jurassic and pre-120 million Cretaceous. Let me read over here. They further state the presence of geochemically dissimilar mantle domains in the vicinity of the greater Ontong Java Plateau, both before and after its emplacement. So there's it suggests that the upper mantle was quite heterogeneous at local scales during late Jurassic and early Cretaceous. Don't know if I put any thoughts on that, so let's just read over here now. Isotopic values of nearby Jurassic and pre-120 million Cretaceous mid-ocean ridge basalts type Pacific tholeiites closely resemble those of modern Pacific mid-ocean ridge basalts. Dissimilar isotopic values between greater Ontong Java basalts and pre-120 million Pacific tholeiites have been interpreted as precluding mid-ocean ridge basalt type upper mantle and favoring a plume originating from the lower mantle as the source of the Ontong Java Plateau. However, isotopic signatures of off-axis, I don't know what that meant exactly, so I just went past it kind of, so let's go past it. The presence of geochemically dissimilar mantle domains in the vicinity of the greater Ontong Java Plateau, both before and after its emplacement, suggests that the off-axis Pacific Ocean upper mantle, whatever off-axis means, was quite heterogeneous at local scales during the late Jurassic and early Cretaceous time. To me, the heterogeneous aspect of it, I guess if I'm going to say anything, was that one side was flowing from the primary mantle puncture hole in Pakistan and going westward through Europe and down through North America below the crust, and then colliding with the other side of that same flow but going the other way, so maybe differentiated so that it kind of was different. And possibly the secondary mantle puncture hole in Ecuador was feeding into this region as well to a bit to create this like difference between before and after. Like the secondary mantle puncture hole didn't happen until like before it wasn't there, and then after it was there, which led to like a difference in the material. Maybe, I don't know, at like 120 million, maybe that was punctured, and some things started happening when that punctured that were not happening until then. Look how many more freaking posts I got. We getting through this, boss and gals. Okay, where am I? Is there seriously all these? Oh no. Here we are. The Ontong Java further has 300 kilometers deep and 1,200 kilometer diameter cylindrical root structure. So this I found. A mantle root. Deep low velocity root. First observation from an oceanic intraplate setting below Ontong Java Plateau. Root has been interpreted as the frozen head of a plume that somehow failed to remain anchored in the deep mantle, but its volume is much larger than it can be explained by the volume of mantle remaining from the melt extraction needed to form Ontong Java Plateau basalts. Mantle roots have also been detected beneath some continental large igneous provinces, Deccan traps, and Piranha flood basalts. I don't know what to make of it exactly. I was thinking maybe it's almost like a inverse volcano. Like currents flow. It's got this continent of Australia above it at the time of something above it, Ontong Java. So maybe not Australia, but Mexico actually. Like this region. Ontong Java is probably forming underneath Mexico in this region, is my guess. Underneath this layer. I mean, there's a circle here. There's like a hinge point, like a compass here. I don't know. It's possible it was kind of erupting in this area. Initially. So maybe there's some relationship to that where it literally made it look like it has some cylindrical the root is cylindrical. Like, that's weird. Some final thoughts from the paper as to why Ontong Java Plateau does not appear to be the result of a mantle plume. So, results from the Ontong Java Plateau are at odds with various mantle plume models for its origin. The greater Ontong Java Plateau cannot be tied convincingly to any hotspot track. Anomalously minor uplifted and placement and anomalously little subsidence since 120 million fit neither plume nor oceanic crustal method models, making the Ontong Java Plateau the only such anomalous feature identified so far in the ocean basins. High degrees of melting at shallow depths are difficult to reconcile with the likely intraplate emplacement environment and the low water contents in the mantle source. The basalts are isotopically similar to some mid-ocean ridge basalts from the Indian Ocean, which again points to possibly the primary mantle puncture hole, like flowing directly here in part. I don't. Platinum group elements are elevated relative to those predicted, assuming a primitive mantle source. A low velocity zone extending approximately 300 kilometers into the mantle beneath the Ontong Java Plateau has yet to be explained by plume models. And then I went back to the Jurassic Quiet Zone. Describing Jurassic and Cretaceous aspects of the Western Pacific by Xiao Dong et al. Something like that, pardon me. Subsequently, massive Sorry. What? I'm not supposed to? Alright, fine. Subsequently, massive magmatic intrusions, Cretaceous, appear to reform the primitive Jurassic crust and its overlying sediments. So let's go back a little. In general, since the Jurassic oceanic crust within the Jurassic Quiet Zone was formed by seafloor spreading, so this is kind of interpretation. Subsequently, massive magmatic intrusions in the Cretaceous. The Cretaceous igneous rocks were cored at these sites, whereas the basaltic Jurassic basement was recovered at Site 801. Therefore, the oceanic crust, which I don't know, I guess I didn't put a picture. Maybe there's a pic note. Therefore, the oceanic crust in the Jurassic Quiet Zone underwent two stages of magmatism: the seafloor spreading and mid-ocean ridge crustal accretion in Jurassic 170 million, and the late stage magma intrusion in Cretaceous around 75 to 125 million. So there's definitely some evidence that Site 801 for the Jurassic 170 thing they're talking about, but I think they kind of do just broadly expanded there for the whole region, and that might be valid, honestly, that the whole region was Jurassic and then it was intruded by the Cretaceous in that time frame, but it may be that it's missing some details. I'm not sure. My suspicion is just based on previous interpretations is that it formed in the Jurassic, and then the Cretaceous influenced it more. There was events in the Cretaceous that overwrote the Jurassic stuff in a way. Maybe it even redated, like reset the date on the Jurassic stuff. I wonder if that's possible. I know that happened, as we saw in the Ecuador. That happened in Ecuador, which is also related to the secondary mantle puncture hole in the angel structure, and so is this region, so maybe it also reset this region. I don't know. The magma intruded into overlying the Jurassic igneous basement has sills, dikes, and seamounts. Dikes and seamounts were formed by central pipe-like migration processes of magma, which makes me think of the huge circles in the Western Pacific there we were talking about earlier, which were able to traverse the Moho surface, oceanic crust, and sediments, and outpour onto the seafloor. In addition, a large number of sills intruded into the lithosphere at various depths, resulting in the increased thickness of the whole oceanic crust. So this region is also a thick oceanic crust. They describe the Moho below the Jurassic quiet zone to have gaps or be missing in places that correlate. So Moho lies beneath the seafloor. It is slightly segmented with small gaps and even missing at some places in seismic profiles. The poorly imaged Moho is found to be correlated with the seamounts. We therefore interpret that the upward movement of magmatic materials from the mantle to the seamount has partially broken the previous ocean crust, and the seamount is a relatively young feature. So here's like where the Moho is broken. Here's the Moho. It's solid, generally speaking, and then kind of broken, seamount above it, seamount's over here where it's broken. Is their interpretation. And then I found this one. We're almost done. We're almost through it. This is the last paper. Last paper, guys. We almost did it. 2 hours. Holy crap. Maybe I'll save this. I gotta correlate it. I'm probably gonna come back to this. Let's go through it real quick. Here's an image. So here's an Emperor Trough. I found this really useful because they got a lot of names to things. Emperor Trough is this like Mariana Trench looking thing I really want to look into further, but I haven't yet. Okay. And I said, while I was rebutting the views of another paper by authors Sun et al., it describes a very curious trend, like a ball picking up speed as it rolls. So I hope you have seen my Hawaii videos where I basically did this. I said like 14, they used to be connected, 14 to 14, 9 to 9, 10 to 10, 11 to 11, 15 to 15 to 15 to 15. All these islands were a single landmass in a sphere shape where this is the inner surface of that sphere. And as this sphere formed at the position we've been talking about. Possibly starting in the ammonite of Australia. It possibly started forming in here and then was like ejected out here. That's what I interpret in my Earth's undercurrents video, but admittedly I don't know for certain that happened, and it could have just formed here at this location, but it definitely was here. And then it ended up going like and doing weird things that I don't know exactly what happened. It ended up arriving at the beginning of the seamount chain where it began to break apart, and that's what happened, according to my interpretation, is that a sphere was up here and it started to physically move, breaking apart as it moved down this way. And then something happened, whether it be rapid expansion of the Earth in some way, or I think this is too late. If we look over, I don't know if I can find it quickly. Maybe this one? Yeah, this one. If we look here, it might have been rolling literally, because it's 84 million. I'm pretty sure it was up here, under the region of British Columbia. I don't know. Just a guess based on some things. I don't know if that's possible. I don't know if it's possible. It might have not been happening there, but it kind of makes sense to me also that it would hit something here. Like, imagine there's a big old sphere under the surface rolling below the surface though, depositing material in the Western Pacific, and then it hits the Sierra batholith here, Sierra Nevada batholith. Like, it hits this region, boom, and it dislodges or maybe it doesn't hit it, it goes like underneath it and like pushes the plates apart, and it dislodges the Pacific plate from under North America and allows it to slide. And then it starts to bend. Like, and then it suddenly hits that corner, and then it's going this way. And it's, I don't know all the details, obviously. There's a bunch of hypotheses going on in my head around it, but it ended up the inner core breaking down into the final islands that are very, like, they're hard to refute if you really look at it. I know people that, like, just like laugh or mock it and would just not look at it, but if you really look at it, like, they actually fit together in a sphere. Like, what the fuck? Kind of means they were once a sphere. Kind of like how the Earth fits together and as a smaller globe. It kind of means the Earth expanded. Same for Hawaii, but in this instance, a little different. Okay, so back to that. So this is why I found this interesting. After extended volcanism early on at the Detroit seamounts, it's kind of just, imagine the sphere is just starting to roll. Extended volcanism. Slow southward volcanic propagation occurred until, so it's going slowly. Propagation sped up from this seamount to this seamount, and then became rapid to this seamount at approximately 53. So this is after the KT boundary, mind you. So if we go back here, so Sweku and Nintoku, so that's around here. Nintoku is the one that looks like a body of a man, I guess. So it's probably not still below North America when it's rolling. Realistically, it's probably not, because it's already moving out. Moving out. Oops. What the? This is a rebuttal paper, so they provide rebuttals here. So I'm just gonna move on. But just that happened was interesting. That I posted this. And then, also quite curiously, the Emperor Seamount, which is before the bend, and then the Hawaiian Seamount is after the bend. Emperor Seamount sits on the seafloor created during the Cretaceous normal superchron, a period of approximately 37 million years that goes from 121 to 84. So basically, when the Ontong Java Plateau began forming thereabouts to when the Hawaiian Emperor Seamount chain began to form, which I believe, when I looked around casually, was around 85 million. So there's this oddity that the Cretaceous normal superchron seems to maybe be when Hawaii was moving from the position of the secondary mantle puncture hole. Like maybe when the secondary mantle puncture hole happened, it moved this sphere of Hawaii away from it, and it moved all the way up to the northern region where it ended up being over here. And then it started to break apart and roll down this way. And that played a part in the Cretaceous normal superchron, the intermediate period where the sphere was on the move. Sphere's rolling out up until it broke apart, during which time the magnetic field did not undergo polarity reversals. Almost like it was interacting with the sphere in some way. Like some deeply rooted way magnetically. Okay, let's keep going. Then I said, wow. Definitely going to find this Sun et al. Paper. They do have a reply to this analysis as well. I looked at the reply. They're pretty much, I posted it here, so we'll get to it. Cite paleomagnetic data to infer that the Hawaiian hotspot moved first northward and later southward. I'm like, dude, I can't make this shit up. He replies with some rebuttals, essentially it just doesn't fit with his interpretation and what he knows. He's certainly well educated. This is literally a rebuttal to this paper by this guy. So it's not like he doesn't know what he's talking about. It's just, it's hard to believe things, but then their rebuttals, we'll see. They're like, we'll see. They're not like that, but we'll see. And I said, for the sphere of Hawaii to have formed under Australia and against Ecuador before moving to where it broke apart in the northern Pacific, it would have had to move north first. And maybe not even left a noticeable hot spot motion northward until it started to break up. So maybe it was like getting absorbed, colliding. Because if we look at this island, it's got these little things here. like several of them. Maybe a sphere ran into it and ran into it, like kind of bounced off it and broke up a little bit to a point where it looked like it deposited some, there was some northward motion of the hotspot, because that's how where the hotspot is coming from, is that it's inducing these things, even though it's a sphere rolling and depositing these things. It's moving northward, but it's like solid and stable until it hits resistance, and then it starts to break up, and then leaves just subtle evidence. It's not conclusive to the point where like scientific understanding is that there was a northward and then later southward movement, but maybe that's kind of what I was thinking. Is like, this is incredible, incredible. I said, so fascinating. If the Hawaiian Emperor Seamount chain formed, let's just read this real quick. The Sun et al. Argument is that the chemistry of Emperor Seamount rocks is similar to mid-ocean ridge basalt in the northern Emperor Seamount. So remember, the inner sphere of this ball is Hawaiian Islands, and then the outer shell is like back. So the furthest, so like inner shell, and then maybe interior but middle shell, outer shell, and then really outer shell. So we're like really approaching like the outer layers of the shell as we're up here of this sphere. So the northern Emperor Seamount, the chemistry of these rocks of the outer shell presumably is similar to mid-ocean ridge basalts, like it was formed in this like under this current flow that was accreting materials, and then maybe it even as it rolled, it accumulated some as like a snowball kind of thing, like a rolling down a hill and becoming a huge snowball. But it shifts to ocean island basalt characteristics in the southern Emperor Seamount. Like it's really getting into the core. Like there's a difference in the material as the ball breaks apart. Different, recognizably different basalts are there. Some authors think that the oceanic island basalt characteristics occur because of melting beneath a thick lithospheric lid. Or maybe a shell, like a sphere that's so massive that it has all the characteristics of a planet, where it has a core, it has magma, it has a crust. Literally is a miniature planet that just didn't quite form, but Earth was like attempting to form. And then it rolled on the surface and broke apart and became Hawaii. It's crazy. Abrupt shifting in Pacific plate motion, or okay. The foundation for the plume motion model is rapid volcanic propagation in the southern Emperor Seamount, where boop boop. This can be explained alternatively by an abrupt shift in Pacific plate motion, which is probably more so the case in the Earth's expansion process. I mean, I guess it's possible it didn't really rapidly expand until actually that moment. Like, I was thinking at the KT boundary, like, expansion started in a rapid session, but maybe it's possible, like, the valves were blowing for like a 20 million years radiometric dating until the actual Hawaiian sphere hit the bend, and then it bent. And then, like, that's when like I was saying earlier, it lifted the North America, or pushed south the Western Pacific plate away enough so that it could, like, get out from under the North American plate crust and float out to the west, and then Hawaii then, like, bent off of the path, as well as was deflected by the interaction with the Sierra Nevada. I wonder if there's any type of evidence over here. Like, this is too young, right? Although it's possible some surface things and the undercrust things don't actually have the same date. But I don't want to take that approach yet until I really feel more confident about certain things. Okay, dudes, we are past 2 hours. Here's the reply. Thank you for responding. We were a little confused. He argued that our paper may be misleading due to sparse data. One of the beautiful aspects of Earth sciences is that we are inevitably faced with incomplete data, and that's basically what they say. The rest of this, you can read it. It's basically explaining, like, there's never complete data. We always are working from incomplete data. And then here is a link to their paper at the very end that I have not read. So I'm looking forward to reading that. I'm definitely going to leave now, so peace out. Thanks for hanging out. I gotta go. This is long enough. Whew, I made it through 2.5 hours almost. Sorry about that. A little long. I maybe should have cut it in half. It's just one thread, one video. It's 369. Damn, she fine. I don't know what to name it. I was thinking about Tesla related stuff. Secrets of the universe. Did he even say that? We don't even know. Or maybe that song. I don't know. We'll see. Peace.